As discussed in the previous lesson, Amazon has three broad categories of storage services: object, block, and file storage. Each option meets a different storage requirement, allowing you to be flexible in selecting and finding the solution that works best for your storage scenarios. S3 is Amazon's highly durable general-purpose object storage. S3 works great for unstructured data, such as media content, static HTML files, and archived documents. Amazon S3 provides the highest level of data durability and availability on the AWS cloud. AWS guarantees 11 nines of availability, or 99.999999999% availability of files on S3. There are three tiers of S3 storage, one each for hot, warm, or cold data, otherwise known as S3 Standard, S3IA, and Glacier. Elastic block storage volumes are the durable block storage attached to EC2 instances used for data that requires long-term persistence and quick access. There are two types of block storage: solid-state drive, SSD storage, and hard disk drive or HDD storage. SSD block storage offers two options: general purpose and EBS provision IOPS SSD for latency-sensitive workloads. Unlike S3, block storage needs to be provisioned in advance, so you pay for it whether you're using it or not. Elastic File System provides simple, scalable file storage for use with EC2 instances with the capability of scale from gigabytes to petabytes of data, without needing to provision it in advance. Amazon EFS is designed for workloads and applications such as big data, media processing workflows, content management, and web serving. EFS is designed to provide parallel shared access to thousands of Amazon EC2 instances, enabling your applications to achieve high levels of throughput and IOPS with consistent low latencies. Optimizing S3 performance involves scaling your connection request horizontally, or in other words, making multiple concurrent requests to S3. There is no limit to the number of connections you can make to your S3 bucket, and S3 isn't a single endpoint or a library of data sitting in one location. It is a massive distributed system, so spread your requests over separate connections to maximize the accessible bandwidth from Amazon S3. S3 buckets are stored in the region you select when you create it, so whenever possible, access the bucket from Amazon EC2 instances in the same region to reduce network latency and data transfer costs. And make a use of AWS S3 transfer acceleration for fast and secure transfer of S3 files over long distances. Transfer acceleration uses CloudFront edge locations. When the data reaches an edge location, it is routed to Amazon S3 over an optimized network path. Use transfer acceleration for transferring gigabytes to terabytes of data regularly across continents, or when you need to upload to a centralized S3 bucket from anywhere in the world. AWS also has a storage service called Instant Store, which is ephemeral storage attached to an EC2 instance. It is only viable during the lifetime of the instance and is deleted when the instance is terminated. As we discussed earlier, Amazon also has storage-optimized EC2 instances, or instances designed for workloads that require high sequential read and write access to very large datasets on local storage. For more information about storage-optimized instances, I've included a link in the further research below.